In our previous video, I gave you an overview of the object-oriented programming concept of interfaces. In this video, I want to give you a code example on how interfaces work. So I talked briefly about two objects, let's try that again. Two objects that were connected with an interface, invoices and employees. Now in our previous hardware store example, we wrote the invoice class, and so to demonstrate how we can reuse that code, I've started a new project in Visual Studio named Interface Example, and I want to bring over my invoice class that I know works and has been tested. So I come to my Solution Explorer, and I right-click the project, and I add an existing item. You would then look for your hardware store example project, find the invoice.cs file, and click Add. You'll now see the invoice.cs file over in your Solution Explorer, and you can double-click it to open it if you would like to inspect it. Also, in our previous inheritance demo, there was the employee class. I'm going to import that class as well. So now I have both invoice and employee in my solution. And so to write the interface that we previously talked about, I'm going to need to come over to my Solution Explorer, right-click on the project, and go to Add New Item. You will find Interface in the list of new items to add. Our naming convention states that we name interfaces with an uppercase I, and I'm going to create the iPayable interface that I previously talked about. So I'm going to name it iPayable and click Add. Just like when we've done this previously to create classes, you can see that our new window opens, iPayable.cs, in a new tab. Instead of a class, we use the interface keyword to denote that this is an interface, and we can see that it's named iPayable. So in the example that we're working on, we basically want to build an application that can determine payments for employees and invoices alike. And we're going to do that through our interface of iPayable. Now, I previously mentioned that an interface is typically used when we have unrelated classes that need to share common methods. So this allows objects of unrelated classes to be processed polymorphically. Objects of classes that implement the same interface can respond to the same method calls, much in the same way that our polymorphic demonstration showed that we can respond to the same calls when implementing or when masquerading as our base class. Interfaces themselves do not actually contain any implementations or code. So we only declare items inside of interfaces as kind of a contract. When they're declared in the interface, they then have to be implemented, fleshed out, and all of the processing steps actually given in every class that implements the interface. So for example, in our interface iPayable, I'm going to declare a decimal get payment amount method. It's not going to take in any arguments, but you can see we end it with a semicolon to denote that we're not going to provide any implementation at this time. So any class that then denotes that it is going to implement the iPayable interface must declare a method decimal get payment amount and actually provide the code needed to make that method happen based on whether it's for an invoice or when we implement it in our employee class, maybe a completely different implementation. But since the method itself is named the same thing, we can share that polymorphically. So in the next video, we'll walk through creating that relationship between our iPayable interface and the employee and invoice classes and setting up this method.